Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 28, 2025, about 3 days ago. The standout result is that Q-tuning delivers a plus 38% average improvement over the full data supervised fine-tuning baseline using only 12.5% of the original training data, reported on the small LM21.7b model. The paper is titled Winning the Pruning Gamble, a unified approach to joint sample and token pruning for efficient supervised fine-tuning. And as we will see, the implications for model training are quite significant. In short, this paper introduces the error uncertainty plane and a two-stage quadrant-guided strategy that coordinates sample and token pruning, setting new state-of-the-art scores across 5 benchmarks while often surpassing full data training. So Figure 1 summarizes the core idea. Efficient fine-tuning comes from coordinating what examples to keep and which tokens to trim. Panel A contrasts sample pruning and token pruning, which target different kinds of waste. Panel B introduces the error uncertainty plane, a map using perplexity and entropy to sort data into 4 quadrants. Panel C lays out Q-tuning, drop harmful noise and redundant knowledge, keep calibration samples intact, and token prune only the valuable misconceptions. Alright, Figure 2 shows the decision pipeline that powers Q-tuning. The plot maps each training example by perplexity, which reflects how surprising the ground truth is, and entropy, which measures how spread out the model's confidence is, so the data falls into 4 quadrants. The method then drops noisy and redundant examples, while keeping calibration and misconception examples. Finally, it trims only the high perplexity tokens inside misconception examples to keep the most informative context. Well, Figure 2 showed the selection logic. Table 1 presents the outcomes across 2 models and multiple budgets, and Q-tuning consistently leads. Keep ratio means the fraction of data retained after pruning. With 12% samples, Q-tuning beats the strongest baselines on both models. With 25% samples and higher token retention, it even matches or slightly exceeds the full data runs, which underscores robust generalization. So Table 1 showed consistent gains. Figure 4 compares independent sample pruning and token pruning across different keep ratios. The message is that even when only one dimension is pruned, the proposed method still leads, which suggests the core design is broadly effective. Keep ratio means the fraction of samples or tokens that remain after pruning, so higher values keep more data. On the left, Panel A places the method at the top across settings. On the right, Panel B again shows the leading bars, confirming robustness. Wrapping up, 2 takeaways stand out. Coordinating sample and token pruning with the error uncertainty plane lets models keep the right examples and trim only the right tokens, and the 2-stage Q-tuning can surpass full data training while using a small fraction of data. The broader implication is cheaper, faster alignment at scale. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.